So welcome to dev.talk. I'm Mark Oliver, the organizer and your host tonight. Yeah, so we have one kind of long related talk today by Andrew, but we'll have a break in the middle for everybody to chat. And that's it, actually. So let me introduce Andrew. He's going to tell us how to level up your DevEx unit test complex E2E flows and integration testing with Aspire and OpenTelemetry. So we're going to welcome Andrew.
I've changed the name of this a few times. This is the latest version, but I'm still not sure if it's the right one. I'm not very good at clickbaity talk names. I need to improve on that. Okay, right. Both of these talks are going to be framed with a kind of scenario. One of the things I don't like is when you read stuff on the internet or see a talk and the scenario is so simple it doesn't really fit to your normal work kind of scenario. So hopefully this is a kind of realistically complex scenario. So start with a user who's going to initiate a process. It's probably going to be an HTTP call. We'll do some validation on the data they send us. We might then create and persist an aggregate. So for that, we'll need some domain events in a database. We might fetch some data from an external service. So maybe it's like an account service or something, check the account's open and whatever. We'll make some decisions. We'll save some more domain events back. And at some point, we might decide that's enough for this synchronous portion of the call. And we'll call out to an external service. And that's going to continue the process. And at that point, we can return an accepted back to the user who doesn't want to wait for the whole process. And this is our API request handler. Meanwhile, the external service or services can send integration events to a service bus. And then at which point we find an event that we're interested in, we can rehydrate our aggregate, do some more stuff, and then maybe save an outbox record. So now we need outbox records as well in our database. Let it catch up. There we go. And then the final bit is something that's going to poll for those outbox records and then dispatch an event back to the service bus. And so this is the kind of boundary of the service that we're going to try and test. And then just for completeness, we've got a kind of webhook service down here that's going to listen to that outbox event, and then it's the thing that goes back to the user and says, hey, your process is now done. And for this particular example, it's a weather forecast service. So this user here has a weather data, weather station thing on their roof, and they're going to submit data to us. And this external service is a contributor payment service that we can use to pay them for their data. This external service here is like a Met Office style supercomputer with a REST API. And we've got a notification service which is going to send the webhooks back. Is that fairly kind of clear so far? Yeah. So the process then, just in terms of a flow diagram, we've got the user that posts their weather data to the API. The API is going to create a pending payment. It's also going to post the data to the modeling system. The modeling system is then then it's going to return back. The modeling system is then going to say either the data is accepted or rejected. And if it's accepted, we can commit our payment. And then sometime later, once it's finished doing its work, it will give us a model updated. And the event listener can rehydrate its aggregate, do its thing, and save the outbox record to the database. And then we've got the processor, which is going to poll for that, dispatch it to the notification service, and then we come all the way back. So hopefully with those two diagrams, we've kind of got a fairly good idea of what's going on. And hopefully you'll agree this is kind of somewhat realistically complex, right? Okay, back to testing. There are loads of ways to test a piece of software. Every organization, every team, every project, even every engineer has their own kind of favorite ways to do things. Now, to start with, I'm not saying this is how everyone should do it. I'm just saying these are some strategies that I've kept coming back to from different organizations, different teams, different bits of software, and they've kind of worked several times, so that's why I'm sharing them. But I've worked in a few places. I've experienced a few different approaches and various phases in the kind of .NET test space. I remember being the first one to write a unit test at one particular company, which was interesting. I can remember the kind of TDD phase with London versus Detroit schools of thought around whether you should be completely algorithmic or focus on behavior. Then there was behavioral BDD with SpecFlow. The first versions of SpecFlow were awful. But yeah, there's been loads of different ways. But I'm not saying this is what everyone should do. I'm saying this might be helpful. This has been helpful for me in a few places. So the first part of my talk is about end-to-end component tests. And really, I'm talking about how do we get the maximum mileage from the minimum number of tests to maintain. So what do I mean by that? I'm just going to have a quick... So when you first come across unit testing, you're basically taught the unit should be as small as possible, right? The smallest testable increment of code. So probably a method on a class, or maybe just a class. So I'm going to say, why can't it be as large as possible, right? Why not? And I'm not even talking about multiple classes or multiple components, but even multiple executables. So in our scenario, that service boundary, we had an API, we had an event listener, and we had an outbox. Why can't I start up all three of those in one test? There's no reason why I can't. People don't tend to do it, but actually there's quite a lot of benefits. So we're going to try and test as much of the surface area as possible, but we're going to be testing behavior, not implementation. So I want to be able to refactor a class, and as long as I haven't changed the public interfaces, so the APIs or the message, the payload of the messages that are handled, then I don't want my tests to break. They shouldn't be brittle because of implementation, right? You've probably all seen tests with lots and lots of mocks for different dependencies, and with IAC and stuff. Sometimes you might have a class with 10 things, and you need to mock them all, and then all you have to do is look sideways at the code before 30 tests are broken or whatever. So where do these kind of tests live? Well, you've probably heard of the testing pyramid, and some people talk about the testing trophy, although not everyone's heard of that. Mine is a kind of testing Christmas tree. So it's these component tests here, and I guess the size of the squares basically represent the amount of them. So these component tests, they run in memory, so that makes them fast. We'll mock or fake just the externals, and we'll test everything from Program.cs onwards. So we still need some unit tests because there's probably domain validity rules and things that we want to test. We still need integration tests because we want to prove that our CI/CD pipeline has worked. We probably still need some official end-to-end or kind of integration tests that test our integration with other parts of the platform. And we probably still need load tests to kind of test the performance, test, first of all, regression. We haven't broken something that we previously fixed, but also a change hasn't adversely affected the performance of the whole system. But yeah, we're going to be talking about this highlighted square for now. So the next question is why would we want to do this? So these tests treat your system as a black box. So that means you can refactor away. I kind of touched on that already. Next point, writing tests is not fun. Some people might disagree with me there, but building a test framework can be fun or can make the test more fun to write, if you see what I mean. Hopefully you'll agree with me later. We can maximize reuse of our code here. Hopefully you'll agree with me once we've seen the code. And I would argue that this strategy is probably less code overall than the equivalent hundreds and hundreds of unit tests that you might take, although I'm not willing to write all those tests and then compare, so I can't prove it. If you get this right, though, it's almost as good as running your service locally. You can actually do quite a lot of development just with these kind of tests because they're so realistic. So what do I mean? What is the anatomy of an end-to-end component test then? So we've got this fixture, which contains some shared state, and then I've got these helper methods below it. So given, when, and then. I quite like Gherkin as a concept, but you could use different names. Then we've got some test classes here, which instantiate a fixture. We'll set up the helpers, which gives us an instance of the given, when, and then we've got our tests. And the tests kind of interact with everything else through given, when, and then, and that gives us our kind of strategy for code reuse. So then over on the right-hand side, we've got an application test host factory for each of our executables. And that gives us the opportunity to kind of override config and plug in our own fake services over the top. Most of you are probably doing that already. And then we've got these kind of fake state here. So I've got my fake service bus, which pretends to be service bus. I've got a couple of in-memory repositories, and I've got a fake time provider. There might be more, but just as a kind of example, these things all live on the fixture. They all get plugged into the application host factories, and then the tests get access to them through the given when and then. Is that fairly, yeah? I should have said we can have questions as long as you're okay with me saying, please wait for the next slide or ask me afterwards, we can have questions. So put your hand up if you want to. So how do we go about doing this then? So number one, make a nice framework. So as I said, I quite like Gherkin. You could use arrange, act, and assert. You could use any names. It doesn't actually have to be 3 of them, whatever you want, really. But you can see here, so I've managed to get 1 line for my setup. So it just gets out of the way. I've only used 1 line. But my fixture is going to set up the helpers and return them in a tuple. And then like this word here, this and, is completely pointless syntactic sugar. It does absolutely nothing, just makes it read a bit more like English. So we can read it, hopefully. Given we have a weather report request for a city or a place, for a time, and out variables. They're a bit out of fashion, but I really love these for this. It enables me to kind of declare it in line where it's first used. I can put my cursor on it and see exactly where else it's used. I haven't had to waste an extra line. I think they work really well for this. So given we have a weather report request and the servers are started, so this is the kind of arrange phase. When we send the message to the API, so we pass in that API request which came out over there, and now we're going to get an out var of response. This is the act phase, and then the response code should be HTTP OK, and the body should not be empty. So what we could have done here is we could have had a specific method here with the assertion kind of hidden inside the method. But what we can do here, because we're going to try and reuse this, why not have a generic, the body should not be empty, which takes the type, and then gives me this this delegate, this func here, or sorry, it's an action, I think. And I can put my assertion at the top level using my favorite assertion library, so this is shouldly, I think. And then I can reuse this in a number of places with the right assertion, but I've still got my reuse. So yeah, hopefully you can see, kind of making methods generic. I've got a couple of overloads of the body should not be empty, so if I don't need this, I don't have to. But because we're going to reuse them, it's worth the effort, right? So that's number one, make a nice framework. Apologies for the amount of code on here. We'll do our best. So component test fixture. So this is the square that was right in the middle, the kind of main bit that holds all the state. So we've got here this area up here where we've got our factories. So I've got API factory, event listener factory, outbox factory. I've also got the notification service factory here, which is just for ease of assertion later on. But those are those main factories which were up in the top corner. We've then got our fake service bus because that's the thing that they use to integrate. Oh, and I should also say this set shared event repository here is my opportunity to kind of say the API factory and the event listener should all share the event, this one event repository mock. Yeah. So that's how the factories are wired up. Then we've got our service bus. Then I'm adding my senders and processors to the service bus. And it's a kind of generic service bus implementation. So we've got a type goes to an entity, kind of like dictionary scenario. And then messages sent to senders will be received on corresponding processors. This is the bit that pretends to be service bus. So we'll come back to that. And then, yeah, we'll come back to the fake time provider as well. So then we need a test host factory for each executable app. This is using this package here, ASP.NET Core MVC testing. Amazing package. I imagine most people have used that. This is a thing that allows us to point at an app. It was built for APIs, but you don't have to use it just for APIs. And then it will run up that API in memory, give you an in-memory client that points directly to that in-memory API. And you can use that to kind of test your endpoints. So it's all based on that. So this is the Outbox application factory. We tell it, we give it a type in the assembly that we want it to kind of spin up. So in this case over there, it's outbox.program. Then we've got the HTTP client will be the in-memory client that points to this app. We've got a couple of bits of state that we might need to switch in. And then in this override create host here, we've got an opportunity to kind of set or override some config. I quite like using environment variables for this because that's what, they're kind of read at quite a high priority by .NET usually anyway. And then we've got this bit down here. If we override configure services, then this is our opportunity to say, instead of the real logger, use our mock logger. Instead of the real time provider, use our fixture fake time provider, and also wire up the service bus. So is that kind of okay? Yep. Right, how do we test with service bus then? Well, service bus handlers, but without a real service bus, I guess. So this was very, very hard until a few years ago when they decided to add the service bus model factory into the service bus client package. Before that, it was very hard because all of the types that you needed were either internal or sealed or private constructors and stuff. But now we have the service model factory, it's actually possible. So I have a thing called a testable service bus processor for an entity name. And the thing that backs it is this list of testable message event args. So that's going to be the thing that we can do assertions against later. So we can say, for this service bus processor, which is for one T, like for one queue or topic, we can say message delivery attempts.count should be 1. And if I go and find the first one, it was completed or it was dead lettered or whatever. So we must override this start processing async, otherwise nothing happens. And there's no documentation for that. It's just one of those annoying things that you only find out when you trawl through Microsoft code. And then I've got this method here, present message. So it's a generic method. The T is going to be the message, and we can test quite complex stuff with this. So we could even test multiple deliveries and exponential backoff code and things like that. But what we're going to do here is create a message args by sending the message in and a few other things. That is going to use that service bus model factory dot service bus received message. So service bus received message is one of those types that you can't new up, but you can use this factory to create one. And there's a whole bunch of arguments. There's quite a long list actually of arguments that you can pass in there. So this is where I'm shoving a correlation ID, some application properties, and that delivery count, so I can pretend to be either the first delivery or the second delivery or the third, whatever. And that all gets wrapped in a testable message event args. And the testable message event args is the thing that gets added to the delivery attempts. And then we just await on process message async, passing in the args. And so as far as your app is concerned, your app is going to request a service bus processor or receiver from a service bus client. The service bus client is probably a mock, and that will return this testable service bus processor. So then when that all gets wired up, this method here will present our args to the app. The app doesn't know it's not talking to a real service bus. And then the app is going to call methods on those args that are either complete message async, dead letter message async, abandon message async. And in here, this is our opportunity to kind of spy on what happened. So in this case, it's dead letter. I can set was dead lettered equal true. I can capture the reason and then return my completed task. And then those properties get set on the testable message event args in the delivery attempt. So that's how we can kind of see what happened. That's probably the most complicated bit. So are we all right with that? Any questions? No? We're okay? Cool. Mock service bus sender. So that was the receiving of service bus messages. The sending is thankfully a lot easier. So we can mock service bus sender using whatever mocking framework you like, or hasn't gone commercial yet, whatever. So you can see here, I'm just doing a verify. I've got a func of service bus message and bool, so it's going to pass me the message, and I should return a bool back to say whether it matches. And I can just do it is service bus message, which matches, that delegate thing. And I can say how many times, I can just literally just use my mocking framework verification stuff for that. But where it gets interesting is if we have a test with two services, one service sends a message to a queue, and then the other service listens to that queue, we need something to wire that up in the middle. And that's where this messages sent to senders will be received on corresponding processors comes in. So this gets run just after the services have got started up, before the test really. And what it does is it says, right, for all of this is on the fake service bus. The fake service bus has got a dictionary of mock senders and a dictionary of testable service bus processors. It might not be the same number in each one, but if we have one in both, that's a scenario where we want to, any messages that get sent to us, we'll go and present them as new messages. So if, for every mock sender, if I have a corresponding process, or if I don't have a corresponding processor, don't worry, just break. If I do, then I can do a setup such that on send message async, I can grab the message, I can grab the properties, and then I can go and get the processor that I know is there because of this bit here, and then I can go and call that present message and shove the message and the application properties, and that therefore kind of present it to the service that's listening to messages. We'll see this in action later, so hopefully that will be better. So, okay, how number 7, database connections. So there's a few options here. I'm just using kind of fake in-memory repositories because my database schema is very, very simple. I've just got a domain events table and a couple of outbox tables. If, like at Flagstone, you have tables that are a mile wide with a million tables with 500,000 columns, then that's not going to work very well. For that, SQLite's probably a best option. Although you can do EF core in memory, but it's so loose, you might end up having code that works in your tests and definitely doesn't work when you then try and use it against a real database. Or you can use a real database. I wrote a little library called C# SQL tests, which allows you to kind of, it'll actually spin up a local DB or SQL in a container, deploy a DAC pack, and then give you a nice little context to run your tests in, and then blow it all away at the end. But it does take a long time. More interesting, bending time. So, who started using Time Provider recently? Yeah, one? Only one? Cool, this is really, really good. So, I mean, forever we've been doing our own date time abstractions, haven't we? Like iClock or iDate Time Provider. Well, suddenly Microsoft have thought, okay, well, why don't we build a decent one and like build it in properly? So I thoroughly recommend you have a look at this. It comes with a matching fake time provider. So we can create a new fake time provider like this. We can do the normal stuff like set UTC now, that's fine, but we've got this really cool auto advance amount here. So what this is going to do is going to mean that anytime anything touches this clock, it's only going to advance by 100 milliseconds. Not at normal time, so I can slow time down and then speed it up again later. So this makes things that are kind of temporarily coupled, which are typically very, very hard to test, much, much easier to test. So what we can do is we can inject this time provider, the fake time provider over the top of the real time provider when one of the apps starts up. This is a piece of code from my Outbox processor where it kind of goes to sleep in between checking, like polling for Outbox records. This is a task.delay, but you can see there's quite a few methods in the framework now which we can actually pass the time provider in. And that means that when the Outbox is waiting for this delay, it's only going to go forwards by 100 milliseconds every time anything touches the clock. So it's not going to find my message until I tell it to. And when at the opportune moment, I can just advance the time provider, and suddenly that delay will kind of finish, and the Outbox processor will find its. So yeah, I mean, anything to do with Service Bus, trying to test it, you have to wait for the queue to be empty. You have to wait for the thing to appear on the queue. You have to wait the right amount of time for it to be processed. All of that stuff. This makes it a lot easier. So yeah, thoroughly recommend having a look at that. Right, time for a demo. I've got a kind of improvised table type thing going on here, so I'm not sure how well my mouse is going to slide around on it, but we'll see. So, how is that for Zoom? I think that's going to have to go with that. Right, so remember the scenario I showed you at the start. This is one class which basically, because I'm using Onion architecture, in my application layer, I can put all my application code. So this handle submit weather data command is hooked up to the API, but also the message handler code is in the same place. So I'll just quickly walk you through, don't worry too much about this, but we're going to see a test being debugged in a minute. But we're going to get our location and our reference and a request ID, and then we've got a couple of services which are being injected in here as well. And I'm going to write some logs, do some telemetry stuff, validate the data that came in, and then write another log. Then I've got some idempotency stuff, and then I'm into this kind of flow here. So this is basically what's going to happen. We've got persist or hydrate here. So if this is a new piece of weather data that's being reported to us, which it definitely will be in the test, then we will be persisting a new aggregate. So we're writing the first domain event of the new aggregate, which is this event here. So it's going to be a weather data collection initiated. And then once we've got that, we've kicked off our aggregate, and then we can do this chained flow. So we're going to check that we can locate the location. We can create that pending payment. That's going to go off to the external service. That external service, remember, for the test is mocked. Actually, I haven't shown you that yet, but we'll get to the test in a second. And once we have created the pending payment, then we're going to submit this data to the modeling service. And that is the end of our synchronous flow. So we're just going to turn the result back into a 200, I think it is, and send it back. Meanwhile, the weather data service will be inspecting the data, and then it's either going to give us model data rejected, in which case we'll revoke the pending payment, and that will be the end of the line. But in the test, we're not going to do that because we've got a happy path test. So instead of that, we're going to get model data accepted. When we get that, we are going to hydrate our aggregate, append a domain event that tells us that it was accepted, commit that pending payment so the user can get their money, and then append submission completed event, another domain event, and that's the end of that bit. So now we know that the weather modeling service is churning away, integrating this new data with its model, and then sometime later we'll get this model updated integration event. Again, we can hydrate our aggregate, append a final domain event, and create an outbox item. So this is kind of transactional outbox pattern here. So we're going to put the last domain event and the outbox into the database inside one DB transaction. So it's a little bit different, and that's the end of the flow. So can you see how that kind of represents the initial scenario, more or less, hopefully? Okay, right, let's have a look at a test for this then. So, this did almost fit on one screen before, but I must be zoomed in slightly more. So it goes from here down to there. So it's almost one screen, right? But this is testing an awful lot. So let's just walk through this. So we're going to set up our helpers. Given we have some collected weather data, there's a thing called canned data here, which, this mouse moving thing is interesting. Canned data is like just a collection of methods that give us realistic test data. So we're going to get our weather data out here. Given the contributor payment service endpoint will return, so here the method names are in the future tense because it's going to happen. I'm configuring something that's going to be true. So that will return an accepted. The modeling service submit endpoint will return an accepted. So under the hood, those are just mocks for the APIs that are going to be called by the system under test, right? So that is our arrange phase done. And then we've got when in phase, and I've got a string here representing the phase, and that's because if we reuse assertion methods in different phases, we want to be able to identify which phase did it go wrong in, right? So I'll just append that phase to the failure message to those assertions. So in phase one, which is the initial API request, so this is the act bit now, we wrap the collected weather data in a HTTP request, which is going to come out here, and then we'll send it to the API, and that's going to give us this response here. So that's that phase done, and now we're into the assertion phase for phase one, right, this bit here. So we can say the modeling service should have been called one time. We should be able to see a submitted to modeling domain event. The response code should be okay, and the body should not be empty. And then we're going to grab the stream ID from the initial domain event, because after that, we're going to pretend to be the modeling service sending those events back into the system, right? So we need the stream ID to be correct for the right aggregate to be fetched. Yeah, with me? Mostly nods, some confused faces, but hopefully we'll see it. We'll see it debugging in a minute.
We've got some PHP developers in
I wouldn't dare insult a PHP developer. Right. So if we've got here, this is the synchronous bit done, right? So we've tested the response was okay. We've tested we've got the right domain events. We've tested that one of our mocks was called, we could do more assertions, but that's enough to say with confidence phase 1 was done. So now it's time for the act for phase 2. So in phase 2, which is the first ASB message back from the modeling service, a message appears. So this is going to call that present message method on the fake service bus, and it's going to be a model data accepted integration event. That will then be picked up by the handler, and in the assertions for this phase, we're just going to say we should have now seen a model data accepted domain event. That's all we're going to assert on for this phase, and then it's phase 3. Phase 3 is when we simulate the model updated integration event. So this is now where the model has been integrated, and we should now be entering the last phase, which is around the last domain event and the outbox record, right? So after phase 3, our assertions are going to be that we have a model updated domain event and a user notification event. That's an outbox record which should have been inserted. And then finally, assertions for phase 4. This is where we use the time provider. So after some time has passed, so we're going to wait for 1 second to pass and then wait 500 milliseconds. That's enough time for the outbox processor to magically find the outbox record and then do its thing. And then we can finally say that this message was handled and the notification service notified the user. So quite a mouthful to explain, but hopefully you can see that test represents the entire happy path flow of that scenario that I presented in the first place. All in one place, reads pretty much like English and not too bad to deal with. So I'm just going to check that I have breakpoints in the right place. I want to check this one here. Yeah.
For your fake timing provider.
Pardon?
Breakpoints and time are the devil.
Well, not so much with the fake time provider. Yeah. Okay, right. Let's... Oh, this mouse is doing my head in. Okay, let's run this now. If I can get my mouse to work, debug. So, first of all, we're going to stop on a breakpoint in the fixture once it's built. See if we can get a bit more room. Okay, so servers are started. So this is the fixture starting up the factories. So if I hit F5, next one we're going to hit is in the Program.cs of the API. So if you can see up there, this is the weather app API. This is run async. So this is proving that the API startup method is being, like the real API startup method is being run. Next one is going to be a program for the event listener. Again, run async. Hit F5 again, and then finally the outbox. So we've got all 3 of our executables up and running now, right? So now we've jumped back to the test. I'm going to hit F5 again. And now we are in the orchestrator. And this is that first method, the handle. Tell you what, I'm going to have to zoom out a minute. Hope that's okay. So this is the synchronous bit. The next breakpoint we're going to hit is down in the location manager. There we go, just to prove to you that it is going into all the right methods. And now we've come back to the test. And now we're in the first assertion phase. So this is the domain event should have been persisted of T. So we can see here that type of T is submitted to modeling. I can get the event class name, which is that there, submitted to modeling. And then I can reach inside my fixture, inside my event repository in memory. Come on. And then if my mouse will work, I can open up that list and we can see submitted to modeling there is the 4th. So we've got our initiated, our location ID found, our pending contributor payment posted, and the one that we were after, submitted to modeling. So I'm now going to remove that breakpoint because otherwise it's going to get annoying. So now we're in handle event of model data accepted. So we're in phase 2 now. So we've done the API bit, we've done the assertions for that, we've created the fake message and popped it on the fake queue, and now it's being handled back in our event listener application. So I'm going to hit F5 again. Can't remember where it's going to stop next. Handle event. Oh yeah, now we're in phase 3. So this is model data integrated. So this time we're going to append the model updated and the outbox item in the transaction. So pop back up to the test, and now we'll go into that outbox record was inserted. So again, I can get my outbox class name, which is user notification event. I can go inside the outbox repository. I can see there's one item in there, and if I have a look at the value, it's can I show you I think I can show you the type. There we go, user notification. So it's in the outbox, the fake outbox repository. So that assertion will pass. And then the final bit, I think, the message was handled. So this is where we can go to our fake service bus. We can get a processor for the integration event. And then if we have a look inside the processor, we've got the message delivery attempts. So there's only one in there, and if we have a look inside it, we've got these properties on here. So was abandoned, false. Was dead lettered, false. Was completed, true. So therefore we know that the message was handled. That's by the notification service. And then I think there's one more assertion. So I grabbed a reference to the real notification service, and then we can just use that to see these notifications in here. And here we go. This is what we're after. Dear user, your data has been submitted and included in our latest model. So that simulates the email or whatever it is going back to the user. So that's the process done. And if I hit F5, we will be left with a nice green tick. There we go. So it's possible to test your entire system in one test in a way that's quite nice to use, pretty thorough. And there's I'm going to go back to my slides before I forget what I'm supposed to be saying. Here we go. So pros and cons. We can test entire end-to-end flows in addition to individual phases. So that was like happy path end-to-end. If you wanted to test some unhappy path flows, I wouldn't recommend having the whole flow. Just set up the portion that you're trying to test and have a bunch of tests that test all of those edge cases and stuff. And those tests will obviously then be smaller, but you can use all the same infrastructure, just start at a certain point, do the assertions for that bit. But the happy path flows, you've almost certainly got more than one flow in your system, right? Like if it's financial services, you've probably got like a payment, then a return or a recall of that payment, or there's a bunch of different flows. For those top level flows, you can have happy path tests. You can run like four tests and know that all the happy path stuff's working immediately. The more reusable the code, the more care or love is justified, I think. So if I was just writing hundreds of unit tests, I would write it as quickly as I could and probably not look at it again. Would I spend time writing nice generic overloaded assertion methods? Probably not. But with this I can, because it's going to be nice for me to use. It's like there's a self-fulfilling thing there. We can also detect config and IAC registration issues here. So a lot of the time with traditional unit testing, if you forget to register a service, your test is not going to help you, right? You don't find out until you try and run that thing either locally or in an environment. Whereas this, if I comment out one of the services that's registered for one of those executables, then this test will break straight away and give me really fast feedback for those that class of problem. So cons, TDD, it is possible, but it's harder, and especially at the start. So if you can imagine, there's quite a lot of moving parts to set up for your first test. But once you've got that, TDD is then okay. And then you still need to run the thing locally to prove that your kind of mocked or integrated behaviors or whatever do match real life, because you can you can kind of get a bit carried away and you're like developing with these tests and thinking, oh, everything's great. And then finally you deploy it somewhere and find that the payload you thought you were getting from somebody else's API is just not right, you know, so you still do occasionally have to run it properly. Yeah, that's the end of the first part of my talk, if that's okay.
We're going to take a quick break. I just want to remind you of our supporters for dev.talk. Bournemouth University, without them we wouldn't be in this room. Thank you, Poole, for organising it, and for Reese for nearly organising it. Thank you. Reconnect conference, the one-day tech conference here in Bournemouth. It'll be in July next year. We've got a really cool lineup already starting to take form for that, so get your tickets while they're still cheap. And Just Pick One UK, which is Kerry's travel YouTube channel. Check it out. If you like it, subscribe. Sorry. I'm supposed to say like and subscribe, aren't I?
Comment, like, and subscribe.
Comment, like and subscribe. Good. Right, we got about 10 minutes or so say hello to each other. I will let Andrew get going. Thank you very much, Andrew.
Okay, so we had the word DevEx in the title, and I've just talked about testing so far, so this is where I get to talk about a bit more DevEx. So this bit started with a kind of mini journey for me, starting with a complete irrational hatred of integration tests. Yeah, I don't know.
Or rational.
Or rational, maybe. So now I'm talking about this level of test above the component test. So this is typically once an application's been deployed to an environment, and then you'd run some tests against it to check that it's still working. So what is the problem? Well, I guess I decided to take a step back and try and ask myself, why do I hate these tests? Why, you know, what is the issue with it? So there's a couple of things. They tend to be like the last task on a story. So you've done the interesting bit, you've done the less interesting bits, and then like the last task is update the end-to-end pack. And you're like, oh no, I wish somebody else picked it up. So when I was thinking about it, I guess I was thinking this. So the loop. Make a change, commit the change, CI runs, we run the release, then we run the test. That loop is way too long. And there's a fundamental problem with that statement, because I shouldn't have to wait for that loop to see my integration test pass, right? But 9 times out of 10, the companies I've worked at, you do end up waiting for that because it's so hard to get the thing running locally. And I think this is the real problem. Integration tests expose how difficult it can be to run things locally. So really what we should be asking ourselves is, what is the problem with local DevEx? So to start with, it's heavily dependent on your compute platform. So you could be using Azure Functions, you could be using app services, you could be using Service Fabric, AKS, you could still be deploying to IIS websites or Windows services or whatever. There's like almost unlimited list of options, and that's all just back-end stuff. I'm sure, you know, if you start thinking about front-end stuff in there as well, then it's even more. There are so many options, and they kind of expose these large differences between local and real running. So let's take one of those things. Like maybe it's an app service or something like that. When we run it locally, are we going to use Visual Studio? Okay, we're going to use Visual Studio. Are we going to run it on IIS, WSL, Docker, just purely .NET? We can use the command line. If we use Docker, we're going to do it manually, or we're going to use Docker Compose. Perhaps we use Kubernetes. Are we going to use Kubernetes? Locally, we can do. We can use Docker Desktop Kubernetes. We could use Minikube, MicroK8s. We might have Helm in there. Should we use Helm locally? We might even have Scaffold, you know, and where do you stop? But you want running it locally to be the same as running it in an environment as closely as possible, because otherwise they're just too different. And you end up wondering, is it even worth it? But we have to do it, right? We have to get integration tests to work. It's not an option. So just a few specific issues. Configuration. How many options have we got for setting configuration for .NET projects? It seems to grow longer, doesn't it, every time you look. We've got launch settings, we've got app settings development.json, we've got Visual Studio secrets, we've got, sorry, my notes are, we've got command line arguments, environment variables, and probably more. And then maybe we'll use some of one type and some of another type, depending on how frequently they change. There's no one place to look. It's just a confusing mess, isn't it? It's getting worse. How about Azure Service Bus topics, subscriptions, and queues? Like, this has been very hard. It's slightly easier now with the emulator that we had recently, but that is hard. Typically, you end up sharing a test namespace and prefixing the queues with your own machine name so that you don't step on each other's toes. Horrible. Managed identity from within containers. I think this might now be possible, but last time I tried, it was not possible. Anything to do with auth, generally, locally, is very hard. You end up with a lot of these. And just the fact that VS or VS Code or command line or whatever is not the same as real running in AKS or Azure Container apps or anything else for that matter. How about Azure API management? If you stick your APIs behind that, it's very good in production, but locally you don't have an equivalent. So you end up with all your services running on different ports rather than different segments from the same. Do you know what I mean? That's not a trivial problem to solve. And lastly, when was the last time you lost a couple of hours of your life wondering why tests run in one place but not the other, just to remember the line ending differences between Windows and Linux? But this is like a personal rant, but I think, I don't know how many of you this resonates with, but in an ideal world, what would I like? I would like to clone a repo, have it restore and build first time, run the non-integration tests, so like all of the, in-memory tests. They should all pass first time. I tolerate running a little local deploy script or command or pushing a button or something, that's fine. And then I want to be able to run the integration tests on my local machine, have them all pass first time, and from there on I should be able to hit F5. Unless I've done something to break it, I should be able to hit F5 and everything runs nicely. That would be great, right? So, Aspire gives us quite a lot of this. How many people have dabbled with, done a little bit of Aspire experimentation? Anyone? No one. Ah, oh, cool. Okay. Right. So, Aspire gives us a development dashboard, which I'll show you in a minute. It's brilliant. It's got so much stuff in it. Your company would never pay you to spend the time to build a purely local development tool that's as good as this dashboard. We get the magic of OpenTelemetry just kind of basically for free, for nothing. This was a really surprising one for me. I thought, okay, if you start a new project, you probably wire it up with Aspire and it'll be fine. But how hard is it to add to an existing app? Well, it's really, really easy. I'll show you that in a minute. And perhaps my favorite thing of all is we can define everything, including all the config for all our apps in one file. It's like for the first time ever, we can stick everything in one place. And it's like a definition of our app. And it supports testing. So, how does it work? Right, we've got our 3 executables. We've got the API, the event listener, and the outbox. And then we've got our external dummy apps. So these are things like the weather modeling service and the contributor payment service. So these are all projects in my solution. These are the ones that are real. These are kind of like mock dummy things. And what happens is, for Aspire, we need 2 extra projects. One is the app host and one is the service defaults. And these arrows here represent references. So we add a reference to the service defaults from all of our projects, and we call one little method. I think it's called set service defaults or something like that in all of our projects. And then on this side, we have one project called the app host, and it has a reference to all of the other projects. And this is where we define the app. So that's kind of how it works, kind of like beautiful symmetry to it. I don't know how they came up with it, but it's really nice. So let's go and have a look and see what it looks like. Right, if my mouse will work, this is. Come on. Oh, I'll tell you what, I'll use the trackpad. So I'm going to go to service defaults first. So this add service defaults, you get this for free. So there's a little bit of command line tooling. You can say, give me Aspire for my app, please. And it will give you these 2 projects. One of them you have to do some work in. This one you don't really have to. So add service defaults. This is the method that you call in all of your projects. It's going to give us OpenTelemetry. It's going to give us some health checks. It's going to add service discovery, which we'll go into in a minute. And then it's going to give us some client defaults. So add standard resilience handler. Don't know if you've seen this, but this has got poly inside it. So this is going to give you like retries and a exponential back off and like a circuit breaker, I think, like sensible defaults for calling, distributed services. And yeah, that's enough of that for now. So that's the method that's going to get called. We'll come back there in a bit. And then this is the cool bit. So this is the app host. So I've got distributed application create builder, and this builder here is then going to be the thing that everything else is hung off. And then you basically just say what you need. So builder.add SQL server, we need a SQL server, we'll give it a name, and I'm overriding the port here. And this magical line here means when the Aspire orchestration shuts down, let's leave the SQL server up so we can still query it and see what happened, and we don't have to waste time building that container again later. So that saves an awful lot of time. Next thing we need to add a database to our SQL server. Mine's called WeatherAppDB. And then I'm adding a project reference to WeatherAppDB. So, sorry. This is a DACPack project. It's going to create a DACPack, and this line of code here is going to deploy the DACPack, the latest DACPack, into that new database. And it has a reference to the database, and it should wait for the database to be ready before it can run.
Sorry, Andrew, what's a DACPack?
DACPack is, so for a database schema, like the definition of the tables and columns in a database, if it's a SQL server, there's a Microsoft technology called DACPack, which will kind of create a script from your schema, and you can use that script to either apply a schema to a new database or compare it to an existing database and say, oh, you're a few versions behind, you should have this column, you should have that table. And you can use that to kind of deploy your schema changes to a database in a source-controlled way. So if we have time later, I'll show you the database project. So what we've done so far is we've added a SQL server, we've added a database to the SQL server, and then we've applied our schema to that database, right? Next thing is Service Bus. So you can see commented out here, we could do something different if the publish mode is production. We might want to add a connection string to an existing Service Bus, but for now, locally, we'll just do add Service Bus. We'll call it ASB, and then we can add these queues. So I've kind of contrived a way to get a strongly typed definition for the queue here. And then once we've defined our queues, we can just call run as emulator. What that's going to do is going to take those queue definitions, build that nasty JSON file that you have to give to the emulator. It's going to do that job for you, and then you'll get two containers in your container host. One is a SQL edge or something like that, can't remember exactly, and one is the emulator itself. So like one's the back end and one's the emulator, and it will take all of those queue definitions, run all of that stuff, and again you can pipe in this container lifetime. That saves like 30 seconds per test, so it's like really significant little line of code there.
So will those be picked up in the next run, the ones that are already run?
Yes, unless there are changes. If there are changes, it will apply the changes, but the backing containers will still be running. So yeah. Right. So the next bit we've got, I'm going to skip over this for a minute. We'll come back to that later. So now we've got our dummy apps. So I've got a reference to the contributor payment service. It's got some HTTP endpoints, and I'm going to exclude that from the manifest. So what that means, that's my way of telling it, this is a dummy service that I want to test with, but it's not part of my application. So you shouldn't consider it part of the main application. You can use Aspire for deployment, and that's where the manifest comes in. I wouldn't recommend it because it's very early. Like, I think even Microsoft realize it's just a cobbled together feature that's not really ready for enterprise use. I mean, I'm sure they'll come back to it and make it really good, but for now it's not that great. So then I've got my modeling service and my notification service. Again, they've all got exclude from manifest. And then down here we've got our actual applications. So here's the API. The API, again, has got external endpoints, and this has a reference to the database, and it should wait for the database. It also has a reference to these dummy apps. And what that does is it will wire up, it will inject environment variables in with the addresses to these dummy apps. So nowhere do I have to say, or I have to remember, oh, the notification service runs on port 5182, and I need to remember that and configure it here. It will go and find that port, and it will shove it in everywhere it's needed. I'll show you in a minute in the dashboard. But that's what it means by service discovery. And then we've got this with environment here. So this is where we can kind of add our configuration. So in this case, I'm giving it a API key for something called queryable trace collector, which we'll come back to later. But with environment basically means I can not have config anywhere else, and I can just shove all the config in where it's needed using environment variables just in the one file. So if you were to look through my solution, you wouldn't see anything in app settings, you wouldn't see anything in launch settings. It's literally all here. I mean, parts of this are very contrived and simple, but you get the idea. And then we've got our outbox. So the outbox has a reference to the database, has a reference to Service Bus, and should wait for it. It's got some environment variables overridden, and it's got a reference to the queryable trace collector. And then once we've defined the whole app, we'll just call builder.run. And that will then, so what we'll do is if we want to run our app up locally, we'll select this project as the startup project, and it will then orchestrate all of that stuff for us. So let's do that. So pretty sure it should already be what I'm going to do before I forget is turn off my breakpoints, because otherwise they're going to ruin things. And now if we go and have a look in Docker, what I previously did was remove these containers so you could see them coming up, but you can see they're already there. So it's very small, but this is SQL Edge latest. That's the backend for the emulator. That's the Service Bus emulator, and then this is my MS SQL Server 2022. So you can see them all running. And then let's see how this is getting on. Right, so it's done its build, it's running up some threads, and then it's going to open my browser. Right, this is going to be a challenge to show. Right, can you see that? I don't think I can go in much further than that, but so we've got here, we've got our Service Bus stuff. So these are running but unhealthy at the moment, but the SQL Edge is up and running. What's that? That's the SQL project. So what you do get is if I delete the containers and then start it, you see it all in sequence going green. But this will eventually all go green. So the queues are now green, the database is green, the DACPack project is run, and then down here, oh, sorry, the DACPack is publishing. We'll just wait for that, which is normally pretty quick. Okay, it's finished, and now the apps will start to come up. So if I zoom out slightly, we can see from this front page here, we've got like the start time, we've got the source, we've got URLs that we can click on, we've got a couple of actions here, we can stop them, we can go directly to logs, and then we can kind of like view details and stuff like that. So if I pick the API and do view details for that, we can see its name, we can see its state, we can see when it started, we can see its current health state, so that's like whether the app's running as opposed to health checks. We can see its process ID, we've got a HTTP and an HTTPS address here, which we can click on. We've got references, these are the other resources in the orchestration that it's got references to. We've got no back references, and we've got no specific health checks, but they would show up here. And then we've got all the environment variables. So for instance, if I want to see the database connection string, I can see that. If I want to see a whole bunch of OTEL stuff that's wired up for me, like we can see all of that. And then if we scroll down, we'll see here services.contributor payment service. Actually, can I turn all of these on? There we go. So these are URLs to the other services that it's just wired in. I haven't had to tell it what port those things are going to be on. it's just going to find them and shove it in there for me, which is really cool. So let's see what else we've got. So we've got console logs. You can select a service. Let's select API. So here we can see what would be on the console for that particular app. We've got structured logs where we can see everything in context together. We can filter, we can search, we can add, there's other kind of filters and things we can add here. And then I'm going to skip traces a second and go down to metrics. So let's pick the API. Now we've got this kind of dizzying array of metrics here, which, I don't know. GC collections, anyone? GC pause time, maybe that's, JIT compiled IL size. Like, I don't know when I might need any of these, but the fact is they're there. Well, exactly, yeah, yeah. I know what garbage collection is, but you get my point. Yes, yeah.
Does .NET not do automatic garbage collection?
Yeah, it does, but you occasionally have to tweak it and tune it.
Your memory interesting ways.
From a Python background, it just works. I don't even think about
No, it'll
garbage
work in the
collection.
background. At some point, it will just kick in though. So it will wait till a watermark, and then it will kick in and start shoveling, and your CPU will get hammered at that point.
And there are different levels of like escalation inside there, and every year it gets better as well.
Yes.
It doesn't sound very good.
It is good. It is good.
It was bad at the start. With core, it's got a lot better.
Yeah.
And it doesn't impact your performance a lot, but it's good to see it because you want to know that you're causing loads of heap objects that are having to be garbage collected, which may be an accidental thing you weren't needing to do.
I guess my point is, I've now got this array of things. If I need them, I can go and find them easily for my running app. I wouldn't, without this, when would I ever instrument some of those things unless I specifically needed them? But now they're all there, and I've done no work to get it. That was my point. So we've also got these traces here. You can see the outbox is constantly polling, and it's hitting the DB every 2 seconds, I think it is. But there's not much interesting there yet. So what we'll do is we'll go back here. Come on, mouse. Right, I've got a polyglot notebook here. And I need to remember to run the first cell, otherwise nothing else runs. Okay, cool. We'll skip over these. Right, I have a bit of C# here. Oh no, sorry, not that one. This one here. This will generate us a new fruity reference. So this one is Tangerine 97. And then we'll use that to hit this endpoint. So what this is doing here is going to take the random reference that we just created, and it's going to post to the collected weather data endpoint with this collection of points here. We've got time, we've got wind speed, wind direction, whatever. This is the data that someone might send us. So we'll send that, and then if I go back to my browser, one of these traces will kind of light up. Come on, where is it? Just going to zoom out a minute to try and... Here we go. Okay, so this is quite hard to show. Yeah. So we've got our post. We can see a domain event insertion here to the database, and another one. Then we post to our contributor payment service. Then we insert another domain event. Then we post to the weather modeling. And here we start getting the event listener. So this is where the weather modeling service is sending us messages back. We're saving more domain events. And then at some point it stops because we've hit the outbox and we've hit the end of our process, automatically traced kind of process boundary. So that's not the whole flow, right? We've got the listening of the polling of the outbox record and the sending to the notification service that's now effectively missing. That will show up on a different trace, but ideally we want them on the same one. So there'll be another one. Well, it will be here somewhere. Do you know what? Take my word for it for now. I'm going to go back to my slides a minute. There. Okay, so what we've seen there is we've got quite a lot of operations traced right out of the box. So whenever we make an HTTP call, whenever we hit the database, whenever we use the message bus, it's kind of seeing that we're interacting with different things. It's passing that trace ID through, and it's wiring up those traces so that we can see them in a span. Really nice. But we've got some missing. So our outbox is kind of like an air gap. Once we've shoved our outbox record in there, then we just leave it, and another process comes and picks it up. That other process needs to know the trace ID if we want the trace to be the full width, right? And also, we might want to trace some more significant events. So that user notification, we're not going to get a trace for that automatically, but we might say to ourselves, actually, that's a significant thing. Why don't we add one? Because it will be nice to be able to see when it's happened. You know, it'll give us better observability. But bearing in mind, this is like dev time, we're now thinking these things, not we've had an incident, wouldn't it be nice if we wrote that log that would have saved us half an hour, you know?
Only half an hour.
Yeah. So let's head back to here, to VS Code. I'm going to stop this. And I've got a couple of bookmarks. So here we go. This is my Outbox repository. So this is where I'm going to save my Outbox records. Now, I've already got here some code which is already being used. Now, this is a particularly confusing piece of code, but this is from the official OTEL.net repository of how you should create a telemetry dictionary with this weird propagator inject thing. I don't really know, but I just took it from the reference. So this is going to give me this telemetry dictionary, and then I can insert that into the database alongside my Outbox record. And that's going to have the span ID and anything from that context inside it. So that's going to end up in my database. And it already is, because this code is not commented out, right? So what we need to do is when we poll for those messages, we will go and grab that telemetry dictionary and set it back into the current activity. Actually, we can start an activity and set it into there. So that will wire that bit up. And then the other thing I said we should do is in the user notification, we should, oh no, what did I just do? Sorry. No, I'm going to do it manually because I don't want to, sorry. Yeah, so what we're going to do here is start an activity called user notification sent, and we can then use that to know when our happy path flow is complete. We can shove the body of the event onto it. We can shove the reference. That's going to be that fruity random reference. And we can also set a timestamp. So, anything that we see and think that could be useful, we can shove it into the current activity, and then it will get kind of passed up to, with the OTEL. So let's run it again and see what difference that makes. So it will run a build because there's a couple of code changes. And then when it's ready, it'll open my browser. Here we go. Right, okay, that was faster. So we'll just wait for everything to run. We can go back actually to here. Let's get a new reference. I know I didn't show it you last time, but Lemon66 is going to be our new one. Right, we can just double check everything's green. Looks like it is. We'll go to traces ready, and then we'll kick off that. And then hop back to here. So this is the trace now. So we've got everything that was happening before. And we get down to this event listener bit here, and then we should now be able to see Outbox item insertion. I'm not sure if we saw that before. We might have done. But now we've got this Outbox dispatch message. So now we've picked up the Outbox message with the other side of the air gap, but the span ID must have been passed through the database correctly because we're in the same span. And now we can see that's been picked up by the notification service. And now we've got this new trace here. If I click on this, we can now see, if I can scroll, here we go. Dear user, your data has been submitted and included in our latest model, Lemon 66. So we've spanned our air gap, we've added some more significant stuff in the trace, and like this trace data is useful, right? It's useful even at dev time now. Okay, let's go back to the slides. Back to integration tests. We started off this talk moaning about integration tests. So the cool thing is, Aspire has a test framework. It wasn't supposed to initially have a test framework, but one of the core team members felt especially strongly that it should have some testability. And David Fowler said, yeah, go for it if you want to do that. So I'm going to show you what it's got. So when you run a test, all the resources are run up. You can obtain a client and you can wait for it to be ready. And you get this passing test from the project template. So you literally do a command line of like add Aspire testing or something, and it will give you a test. All you need to do is change the name that you gave to your API. So I had to change whatever the default was to API, because that's what I called mine. And it runs. And from that, you can kind of use that as a basis to build some tests. I'm just trying to... Oh, yeah, cool. Right. So let's go back to VS Code. I'm going to stop this. And we are going to go to here. Let me go to Zen mode. Right, this here is the test that you get out of the box. So if we read this, this time we've got a distributed application testing builder, but we're going to point it to the app host. Remember, the app host is the thing that's got the definition of our entire app. And we're going to add logging to it for some reason. Going to set some, I don't really, this is out of the box. I don't really know why this is doing this. We're going to configure some HTTP client defaults, so that's going to give us the poly retry strategy and stuff like that. And then we can do app host build async and wait for it to build. And then we can do start async, wait for it to start. And once it's started, we can grab a client to the resource with the name API. Once we've got that client reference, we can wait for the resource to be healthy. And once it's healthy, we can call get async against it, like just get the slash, hit the slash endpoint. And then we can assert that that response status code was equal to OK. So this test then runs out of the box. So I'm just going to prove that to you by running it. And whilst we wait for that to run, you can imagine now, so that's that you've got a test which hits your API. That's the first synchronous bit done. You can check that you got the right response code, you can check that your body was correct and all the rest of it. What about the next bit? This is a start, but the next bit is particularly torturous, right? You have to wait the right amount of time for the message, or check that the message is not on the queue. Wait the right amount of time for the message to have appeared on the queue. Wait the right amount of time for your handler to have handled that message, and then check that the message was not on the queue, but also that it didn't hit the dead letter queue. Even then, are you really sure it got handled by the right thing? Not always. Like you might also have to delve into the database. So there's like a whole lot of nasty things that you can do after this point to try and figure out what happened in the scenarios. Okay, so it passed. Right, I think I'm going back to here. Is this my next bit? Yeah, I think this is my next bit, sorry. So if we think about it, that trace data we were just looking at in the traces tab is like a gold mine of information about what just happened in our app. Why can't we use that to prove that the test worked? Like, why can't we use that to assert against? And like this was a bit of a kind of eye-opening moment for me. I was like, hang on. I know everything that just happened without having to delve into the database, without having to do these weird service bus interrogations, without, it's all there. So I thought, and it's like a single place to query. But this is where my excitement kind of hit a brick wall. The dashboard doesn't get run up during the test, and it's the dashboard which is wired up as the gRPC kind of endpoint for OTEL. So all of your other resources send their OTEL data to the dashboard. In the test scenario, the dashboard's not run. You can flick a switch and get the dashboard to be run during the tests, but even then, there's no public-facing endpoint to query the trace data. So you want a programmatic way to do your assertion rather than having to look at the trace tab, right? You can get access to the, I think it's like a query, trace data query view model or something, but it's private, so you have to go and do some reflection and some nasty stuff in the IOC container. And even then, I couldn't get any data out of mine. So I thought, okay, we need a better way for this. And when you think about it, it needs to be something out of process, because all of these different containers or apps running in different processes, they all need to send their data somewhere else. So you can't stick something in memory. It needs to be a separate thing. But Aspire is extensible. So I came up with a thing called the Queryable Trace Collector, which consists of a hosting package and a client package. So the hosting package basically says, go and grab a container image off Docker registry and run that up. And then the client package basically says, it adds to the service defaults, and it says for each of your apps, also send your trace data to this API over here on this container, and like sets up an API key. And all it does is a container with a very, very simple in-memory collection behind an API. We can use that to receive a subset of the trace data, and then we can query against it as well. So remember this diagram here? What normally happens is they all send their trace data to the dashboard. We don't get the dashboard when the trace run, so we've got our queryable trace collector. We'll send all our trace data there instead, and then our tests can kind of either clear in between tests or read and assert from the queryable trace collector. Okay, so let's go and have a look at that. How are we doing for time?
You're rapidly running out. You've got about 2 minutes.
2 minutes. Okay, right. I won't show you what the queryable trace collector looks like to wire up, but I'll just show you this test here. So this test looks quite similar to the tests we looked at in the first half. We're going to set some stuff up and run up the Aspire kind of orchestration. Then we're going to send the request off, wait for an OK back. And after that, it's very simple. We can just poll, until we've got at least 8 traces, including the magical one, user notification sent. All we have to do is poll until we've got that. Once we've got that, we can say, right, we should have had these domain events in the domain events, in the trace data that's come back. We should have an activity called outbox item insertion, and we should have the magical one, user notification sent, with the dear user sentence and the correct reference. So if I run this, we'll see. I mean, it passes. It's going to be boring watching it try and pass. So what that does is it runs up that extra container, service discovery injects an endpoint for it and the API key for it into all the apps. There's a place where I say these are the only activities I'm interested in, because I don't need the whole of trace like OTEL. It's like a fire hose otherwise. We just want certain activities. They all get sent to this little in-memory API, and then we poll for that here. Why is that not on? Yeah, we poll for it here. Right. Oh, I scrolled up. Yeah, there you go. So green tick. So it did pass. And yeah, I think I have 1 or 2 slides left, and that's it. So pros and cons of this approach using Aspire then. I think it constitutes a pretty massive shift left in a lot of different ways. Mostly it makes it easy to kind of realistically run the service locally. It makes it much easier, I think, to write integration tests. Hopefully you might agree to that. And you could even say, is this a new thing, observability-driven development? Because we're making that trace data more valuable at dev time rather than waiting for that incident where we wished we'd added a log. Like, we're now saying, if I add decent trace data, it's going to make my testing life easier, and definitely my running of the service life easier as well, right? I tried to think of some cons, couldn't really think of many, scraping the barrel, but you might have to create dummy or mocked external services, but I think you probably would anyway. So next stages. How does the opinionated nature of Aspire fit into enterprise CI/CD pipelines? I don't know. I don't think it does yet. Next question, do we still need those end-to-end component tests? I think we do, because these still take a fair bit longer to run. It's something like 7 seconds versus 25 seconds, so still a little bit quicker. But we could probably also assert against trace data in the component test, maybe. Haven't tried that yet. Yeah, these are some various ways you can reach me. All of the code I've showed is at this GitHub repo, which I write, or it's just like one place where I do all my code for talks. So please go and check it out. And if you've got any questions, we don't have much time.
Great.
Cool.
Thank you again, Andrew.
That's all right.